mean, it's going to be one of the most easily joins I've seen for a meeting in a while. That's awesome. With all the people that have already showed up, I think we should just get started and respect everyone's time. Thanks everyone for joining. Mindy and I have been trying to kind of pull people together and expanding the Denver data analytics world, finding smart people. All of y'all are really thoughtful and know other good people in the industry, whether in Denver or elsewhere. And so there's been lots of questions about resources and tools like R and Python. We're hoping that this month we can do a series of talks to help us all get out of using just one and start using more tools. So hopefully, Mark today is going to kick us off with an exploration of AWS. And we're going to follow it up with later next week. We're going to have a look at Colab, which is a Google platform, much like Jupyter Notebooks. Mark Ballard's going to talk to us about SQL. After that, on the 16th, we're going to explore R and a workflow for looking at LES files. And then possibly the 30th, I think we're going to add a Python web scraping look. So it should be a real fun month. As you guys have questions, things you might like to see in the future, please reach out to Mindy or I on LinkedIn or on our emails. When we've not been in the COVID times, we've been doing monthly meetings in Denver, just having people present about their tools that they've built, workflows they've designed, trying to avoid getting into proprietary data sets, but just helping us all know more smart people, get better ideas of how we can do our work better, and how to highlight good people in the industry. If you'd like to speak or if you have things you'd like to see spoken about, we'd love your input on that. And with that, we'll kick off Mark's talk today, and hopefully we can have some good discussion during and after this. Thanks everyone for joining, and Mark, take it away.
Thanks, Kurt. Well, first off, thanks for everyone for their time. I recognize a lot of the names on this menu, and definitely wish I was in Denver instead of in Houston, where it's cracking 90 some odd degrees already. So, sincerely hope everyone's doing well and that you're staying healthy. And I think this is really a talk that will go through our experience. As for those of you who don't know, Q Engineering is a startup that my partner and I founded about 3.5 years ago now, and we were able to successfully exit to Drilling Info 6 months ago. And a big part of the reason why we were able to do that is our adoption of Amazon Web Services, and specifically the ability to combine cloud computing with a user interface that's familiar to our clients. And while I think we were probably the first to do that inside a Spotfire environment at scale, I think our experience is certainly not unique. And in fact, I think just about everybody's a user of cloud technology, whether you know it or not. So it should hopefully open the floor for some discussion. And I'm happy to answer any questions you guys may have as you go along. So feel free to type a chat, and I can address the question, or you can unmute yourself and ask, and I'd be happy to get the discussion rolling. Okay, so our solution was a little bit unique because we were basically in love with the Spotfire front end. For those of you who don't really know what Spotfire is, it's basically Excel's charting on steroids. And
Hey, Mark, you cut out there for a little bit. I don't know if that was on everyone's end.
all right, well, let me back up. Can you guys hear me now?
I'm good now. Yep. Oh, I think we lost you again.
Oh, no. How about now?
Yeah.
Okay. So I think that again, Spotfire is the platform that we were using, and we used it because can you hear me now?
Yep, you're good now.
Is what robust graphical and an ability to write code, but also something that I think most of our customers are already familiar with using. So rather than writing a whole fresh web interface, it was important for us to go ahead and maintain the analysis actually in Spotfire. And what our customers did with it is they were able to run billions of simulations a month. And we've created at this point roughly about 15 million type well predictions. It was a pretty short ride. We started growing and scaling the company about 2 years ago, and it scaled that for roughly a year and a half before selling. So it was certainly something where we took advantage of the scalability of the cloud. And my goal today is not really necessarily to tell you how we did what we did or really how our tool works, but what we used Amazon Web Services for, and hopefully that inspires you guys to start thinking about your own jobs and your own kind of pain points, and start using or taking advantage of the cloud as a way to solve for those pain points. Our timeline, just to reiterate that point while I talk about this, the cloud in specifically Amazon Web Services is basically an entire
will be there in a minute. We're flip.
An entire ecosystem of the world's best IT professionals, server architects, network administrators on demand. And so the way their business model works is it's free basically to test out an idea. And when you start getting a lot of traffic onto the network, then they start charging you. And collectively, what that does is remove any barrier to entry for any idea. And if you've got an idea, or if you've got some basic ability to code, or basic ability to utilize a SQL Server database or in workflows, you can get started on Amazon today and start testing your solutions. The benefit is once you're ready to grow, or if you wanted to share it with your colleagues, it can be easily kind of transferred to any architecture that you may be using professionally. And that's really, I think, the key thing to keep in mind is that the cloud really is, not this fictitious architecture. It really is just the same types of things you would see in a physical environment or in an on-premise data center, just exposed in the cloud and configurable via a web browser. So you don't have to worry about acquiring new equipment. You don't have to worry about making sure things work. You basically get the opportunity to start very small and basically free. And when you need the additional bandwidth, or when you need additional storage, or when you need additional compute, you're able to dynamically scale those components individually to end up with a very robust platform from the go. And just for a little bit of orientation, if you look at the graph on the right, Amazon's kind of logically broken up into lots of different modules. So if you log into the Amazon Web Services webpage, you can really see several different options. It might feel a little overwhelming at first, and I will say the technical support articles are maybe a little dry and hard to read at first. But in the last 3 years, the amount of technical resources available and help guides and tutorials or even chat rooms that have helpful features has really scaled exponentially, and it's significantly easier to do now than it was even when we started. And kind of the modules I'm going to be focusing on here are Amazon's computational tool sets. So Elastic Beanstalk, which coordinates and automatically scales computational resources on EC2. And then AWS Lambda, which is a serverless computing application really designed to be a quick interface between short bursts of information and the architecture on your system. On the storage side, Amazon has a Dropbox like S3 and a traditional kind of relational database service called RDS that has all variety and flavor of SQL databases for configuration. And then I think finally, we can talk about using an API gateway or even Docker in terms of implementing more robust solutions and really giving you all the tools you could possibly need for scaling. It's kind of an interesting thought. Anecdotally, we got into using Amazon Web Services because we were in a client meeting with a guy, and we were showing him our solution. And at the time, we had written our forecasting simulation in a Java application, and so you kind of had to install it on your local machine, and we were able to interface with Spotfire locally that way. And we were showing it to somebody and asking him kind of for some feedback on our solution, and he just kind of flippantly said, "Why aren't you guys on the cloud?" And our first, brush at that question was, well, I mean, the cloud's kind of complicated, isn't it? I mean, wouldn't it take forever to build the solution and launch it on such an unfamiliar, untouchable, untangible kind of resource? And we left that demo and with some good feedback, but we immediately started going to the Amazon Web Services site, and we started looking and trying to piece together all of this. And if it wouldn't have been for that meeting, we probably would have failed shortly thereafter. But the cloud really allows you to write code and appropriately scale the resource to use that code, and then make sure that on a security basis, you're taking advantage of world-class cybersecurity experts at Amazon to secure the kind of the security of the cloud concept, while following kind of the best practice and recommendations to secure your own instances inside of the cloud. I mean, the amount of things that Amazon does for you to make it easy and appropriate to store the world's most sensitive information and to connect it securely so that you can serve it on demand to necessary applications is pretty mind-boggling. I mean, even the CIA stores significant chunks of their data on the Amazon Web Services infrastructure. So it's a helpful reminder that the solutions that you can construct are not only quick and easy and flexible, but they're also exceedingly secure from an external perspective. Okay, so just to give you a little bit of an idea of what we did and how we used these tools individually, I'm going to break them up into a couple of different examples. And apologize to any of you that might not be directly in oil and gas, but on the right-hand side of the chart, you're looking at a gas rate on the y-axis. Notice the log scale there, and then a normalized months plot on the x-axis. And each one of those red circles is a result of a MATLAB plot of actual data points of a particular well. And you can see on the right-hand side in black, well, in the middle, but each individual realization of a forecast in gray. And one of the things we did at Q that was very unique is rather than kind of stealing or steering our forecast by using regression from point to point, we did not regress our or try to optimize our simulations at all as they're running. And so we wanted a system that was able to generate 25,000 solutions. And while somebody was using that particular computer, it could immediately kind of scale computational resources up to allow people to run simulations kind of on the fly. And we were able to take advantage of the Elastic Beanstalk tool set, which gives you EC2 instances for compute, and then will automatically multiply them as your demand increases. And this allows us to run a very technically robust solution on the cloud and not lock up our desktop resources, but also ensure that there was no waiting in line for a computer to finish, and we could go ahead and serve multiple clients simultaneously. And we've even tested the system up through in excess of I believe like 10 million simultaneous requests, and it's as you can appreciate, a lot of hard work has gone in behind the scenes that we get to take advantage of as a startup. And so just kind of helpful description for what that looks like on our side. But we also used a significant amount of Lambda, of AWS Lambda, and then later Docker to really optimize the kind of quick feedback loops that a lot of the user interface needed to drive calculations. So if you were to try to do something very simple, things like average a data set, maybe write some basic reports, and ensure that a user is licensed, for instance. Amazon's Lambda service allows us to do this in a serverless fashion. So we don't even have to think about provisioning a server for partial time. We don't have to think about the Elastic, Beanstalk kind of scaling capacity. We just write code and store that code on AWS Lambda, and it generates through the API gateway an address for that particular function. And so any computer from anywhere is able to use that address from the API gateway to coordinate with an Amazon Lambda code block, and you're able to perform those very quick functions, maybe retrieve some information from a database, potentially encrypt files for storage and transport up to S3, and really a whole host of anything. There is a pretty significant catch, and as we grew and as we scaled, one of the things we ended up doing was moving away from Lambda down the road and towards a solution called Docker. But Lambda has a timeout in a pretty restrictive data cap. So if your solution or your architecture requires a significant amount of information to pass back and forth, or consistently runs into timing cutouts, Lambda might not be the ideal solution for you. And you can move to a very similar structural component in terms of flexibility, but much more robust in terms of capability through a containerized application service like Docker that you can do all kinds of really neat things in terms of tying multiple services together and then spooling up a whole set of options and kind of keeping everything in one little box, moving around the loop. Another example of this is as you're interacting with the user interface, we do a lot of calculations where you would calculate a forecast and then have that new forecast kind of display against a backdrop of more or less static data. And Lambda was another good way for us to really use the user interface and keep it fresh as well. Visually, I think the point that I'd like to make here is, Amazon's got a lot of tools, but I think it's very important to always remember that if you try to approach a solution with some cool bit of technology as a kind of first priority, a priori kind of workflow, what you tend to find is you try to fit a lot of square pegs in round holes. One of the things that we did right is to kind of think about the entire workflow, start to finish, and make sure that our software followed that workflow and not the other way around. And eventually the solution is the result of kind of doing things in the right order. So, try to be flexible with the maybe functional building blocks as you go, and make sure that you are constantly checking against kind of the reference or the outline that you set out at the beginning to try to attack or accomplish. With that, and I think just kind of to leave this up as a backdrop for questions. How can I be helpful, or how can I encourage you guys to go out and conquer the world with small scale, scalable cloud solutions in your day-to-day jobs?
I'm seeing a lot of Amazon on the screen here. Are you required to use Amazon, or can you combine Microsoft, Amazon, other products?
Yeah, I would encourage you to pick one and stick with it. We chose Amazon because at the time, 3 years ago, they had far and away the most documentation on their resources. But the cloud game obviously has continued to heat up since then. Functionally, they're all, they all contain about the same stuff. So with some differences, obviously, but I think there's even a lot of effort in Silicon Valley right now to build a basically cloud agnostic import export tool, so you can move, like if Amazon starts charging you too much, you can just move your solution to Azure, for instance, and not have any hiccup. Or some clients really, for a lot of different reasons. So yeah, the actual cloud itself is not important, but the resources are generally consistent across clouds. But I would encourage you to pick one and stick with it, not try to go back and forth.
Hey, Mark, I got a question for you.
Yeah.
So, can you comment on transferring large data volumes to and from the cloud? I mean, it sounds like we're talking a lot about computational power, which is great, but I'm thinking, if we're using like large images and transferring to and from local storage versus cloud storage to leverage cloud computation, can you comment on some of the costs associated with that part?
Yeah, great comment. So just for a little bit of reference, you can do quite a lot with JSON. So you can, 64-bit encode anything you want and send it up and down. But there is a practical limit in bandwidth through, that kind of architecture. For large scale data volume moves, what we found success with is to actually transfer zipped data volumes up to S3 and have Docker then access it from there.
Cool, thank you.
Yeah, of course, great question.
Mark, when you're using I guess I'm not sure exactly which. I think it's in Docker, but in the different modules, are you able to work in Java, C Sharp, Python, or whatever? Are you skipping around and using the one that's most appropriate for what you need, or how does like language? What kind? Do you need to know a specific language? Is there an Amazon specific thing you need to know, or can you work kind of in whatever you want?
Yeah, I think as a general rule, it's exceedingly flexible. Just for convention, we wrote our simulation in Java for its speed, relative just being a more or less machine language. It was important for those simulations to be written in a very fast language like that. But Python works exceedingly well in Lambda and Docker, and you have the flexibility if you want to use a different language resource there as well. So I think I don't think R is necessarily supported, although that may have changed since now. But R is native to Microsoft's RDS, so you can get it. Any other thoughts?
This is Marisa Michalowicz. I have a question. Does AWS support you well with all of these efforts that you are undertaking on their platform? Can you tell us about your relationship with them?
Mm-hmm. Yeah, so we are an AWS partner. Signing up for that status is fairly straightforward. They ask you to kind of fill out some information, and they, as a bonus, they provide you generally with some computational credits and offer a lot of training. So we send our developers to AWS school to become certified. There's quite a lot of technical resources directly provided by Amazon. They have an office down the street from us in Houston. I guarantee you they've got one in Denver as well. And they were helpful in coordinating. But I think one of the benefits, not only was AWS kind of generically pretty helpful, but a lot of companies and resources are able to share their experience on the cloud, and so you can find a lot of helpful consultants and such that have experience fairly easily.
Great, thanks.
Mark, when you got started in AWS and had some of your first first trial attempts of using it, what did that kind of code, or how did you kind of start going from 0 to 1, I guess, on the first scripts you tried to pass into it and getting comfortable with how to scale? I mean, before you even started scaling things, just trying to get the first couple of calculations running.
Yeah, so we had a significant amount of frustration trying to get the chunk of code running. It's pretty easy to interact with the interface, but one of the things we learned is that if you're writing Python, it was much better to be in a Linux environment or a Mac environment than it was to be in Windows. And so switching to a Mac developer environment, helps speed up quite significantly. In the early days, we had a Linux box that we used for the first kind of pass. But Lambda in particular, I think, is the easiest one to really kind of highlight. There's a lot of things you can do with Lambda, and it has the advantage of being an all web GUI. So you can write code, you can pass it a JSON instruction packet up front, and you can actually run test events live from your browser. So, the ability to basically check it before it goes into production on the gateway, and kind of follow the best practices for DevOps, where you basically make sure it works before you check it into production. It's pretty straightforward and simple once you get past your first little hiccup there. A good question.
I had a question. So AWS, yes, but do you have any experience with comparable tools on other platforms?
Yeah. Yeah, I personally don't, but our developers definitely do. Google has been a pretty, has done a lot of work. I think they were first to the Docker game in particular, but Amazon kind of copied that very quickly, and Azure, I think I've heard some really good things about that recently as well.
Do you mind me asking what your how much cost you're spinning up? I mean, on a relative scale.
Yeah, the cost for operating a SaaS product is not really important. On a relative basis, you end up spending a lot more of your resources, obviously, on G&A and your sales organization to try to scale. That I wouldn't worry about the AWS costs early on. I mean, it's free to try something out across the board. So you're kind of able to adjust that up and down as your needs go up. So they tend to scale with your revenues.
Hi, Mark. This is Ben Burke. Question for you on your entrepreneurial experience. You mentioned the move to the cloud as being a kind of in hindsight, a key one. Were there any other key pivot points in your entrepreneurial journey?
I didn't have, neither my partner nor I were developers before we started our company. We kind of wrote hacky programs through as a part of our day jobs, but making the leap to commercial software was a lot harder than we thought it was going to be at first. But once you kind of cut the umbilical cord from the W-2, there's a significant amount of clarity that comes from not getting paid until you sell something. And we were able to take advantage of that. I think the other thing I would point out, everybody I ever worked with wanted me to succeed, and it doesn't matter like how early on we were or how poorly our software worked in the beginning. We had people that were really willing to root for us, and I would say even universally offer advice or help, regardless of what we were able to offer them at that period of time. So the ecosystem of starting a software company is pretty altruistic, I would say, in our experience. And I'd love to catch up with you and answer your questions kind of in more detail, and encourage you along the way.
This is really good. It's got me, I've got a latent account sitting with AWS that I haven't used. And I think this is enough to get me kicked off to actually go try and dust it off and put it to work. Is there any questions or some interests in for Mark before we wrap this up? Well, I want to thank Mark for presenting. I think there's a lot, obviously there's a lot more that we could dive into on the details, and the goal here is to really kind of encourage, help us get cursory overviews of some of these tools and get a better sense of how they operate, so we are more comfortable diving into them. Hopefully, everybody has a little bit more of a better sense of how Amazon Web Services, as one example of some of the cloud-based tools, operates. And I hope a few of you might even venture into using it in your workflows or designing something new. I know that in the future, there's been many organizations, including ours, that have talked about hackathons. And so maybe there's some way we can incorporate an AWS sort of challenge or utilization in the future as a way for us all to practice a little bit and get more comfortable with how these things operate. If you have ideas in that regard, please reach out. We'd love to explore putting something together. Mark, this was awesome. Thank you so much for taking time to put this together for us. And I really appreciate everyone joining. And I look forward to seeing y'all face to face soon and keeping this series of talks going through the rest of the month.
Well, Kurt and Mindy, thank you so much for inviting me, guys. I put my email addresses in the chat room, so please don't hesitate to send me any questions or follow up thoughts. You know, I really learned a lot from my experience and would be very excited to help anybody that's taking a look at this, either for entrepreneurship inside their existing company or entrepreneurship to step out on your own.
Perfect. Thanks, everybody.
All right. Thank you, guys.
Thank you, everyone. Be safe. Be healthy.
All right. Bye-bye.
Bye.
See you later, man.